Okay. Okay. So we're going to start now, and we're going to start with a presentation. So this is not about flower turbines, the technology. We'll talk about technology a little bit in terms of how it relates to what we're doing, but we're talking now about the company Flower Turbines Project Series 1, which is a separate company, which is going to do projects with flower turbines. Okay. So let's now look into that. Okay, so that means it's a little different. Um, that when you have projects, it's a little bit of a safer investment. I'm not allowed by the SEC, by the way, to say anything is safe, but I think everybody knows that it's tends to be uh, safer because you're investing in things that produce electricity, that produce something for people than in the technology itself, which can go up and down. It can go a lot higher. I'd say it's like the difference between investing in Microsoft versus investing in Con Edison, something like that. Uh, Con Edison gets money from selling electricity. So we can also support a cleaner environment. And obviously, we're in the middle of a crowdfunding session or a time right now. Um, let me just go on to the next slide. And this is repeating what you saw on the website. These are some of our validations: U.S. Department of Energy, Dutch Sustainability Award, yes, San Francisco Clean Tech Competition, um, and being on TV and that kind of thing. And we have a good team. So let's get to what counts. Um, Small wind generally hasn't lived up to its potential for a number of reasons. And the biggest ones are that usually low noise and efficiency don't mix. Um, and turbines close together interfere with each other. You've probably seen that in the big ones if you've ever been in Iowa or something like that. You'll see how far they're separated. That means they use a lot of space. A lot of people don't like how they look, and they are dangerous to birds. So that's part of the reason there hasn't been a fund like this before that deals with uh, small wind turbines. So ours answer all of these, plus they start at low speeds and they survive high speeds, which are usually two things that don't go together. Just like usually low noise and high efficiency usually don't get together. But we've solved both of these things. Um, so the key to making cost-effective small wind projects for the first time is the higher efficiency, especially our larger models. The larger the turbine gets, the more efficient it is. And they have an aerodynamic efficiency of over 40%, which is really close to that of the modern large turbines. Uh, they have lower starting speeds because of the way we designed them. And the projects are at the point of use. So what that means is that we're not competing against the low prices that a utility can get from a huge wind farm or a huge solar farm or a big gas plant. But what counts is what is the price for the consumer, whether that consumer is an individual or a business, at the point at which they are paying money. And so there are no transmission costs and losses involved, no bureaucracy to pay. So that's the key distinguishing feature here. And then the big reason of why it's the first time that anybody is offering small wind projects is that we have what we call a bouquet effect or a cluster effect. It means that each turbine that you add to a project makes the whole group perform better. So each one improves the return for the investor. And that's key because instead of just doing one turbine here, one turbine there, we're making many together. And that's a granted patent. So that's another reason that nobody else has done this before. So let's look at the technology a little bit. This is a horizontal slice through our wind turbine. You can see one blade here, one blade there. Red is the highest speed wind, blue is the lowest. Here the wind is coming from this direction at yellow speed. It first hits the first blade, then it recycles into the second blade. If you look very carefully here, it becomes red in the middle. In other words, it actually becomes faster than the outside air because of another patent, which has to do choosing the right ratios between the blades, their size, and the shaft, so that you get the minimal friction, but the maximal concentration of the wind after it hits the first blade. Now, the important thing for our projects, aside from the efficiency, is the cluster effect. So you see that next to the turbine as it spins, there are areas of red. In other words, it creates wind tunnels adjacent to the turbine, which means that if you placed another turbine here and another turbine here, they would capture all of that higher speed wind. So that is how it works. Um, And how does it work in practice? So that technology you see here, that when you have four turbines together, it's already producing double the amount of power that you get from just one turbine alone. So that's a very powerful effect and very significant. Now, from the design of the turbine itself, you can see that most turbines only start producing electricity here. But in this particular one of our tulips, it's already producing over 30 watts um, at the same point where others are just starting. So these two efficiencies make it easier for us to make cost-effective projects. And if you look at a northern place, and we calculated this based on Cape Cod, and you compare solar to wind, it's a northern area, it's a windy area, is that we can do a little bit better than them in terms of the payback. However, the revenue per square meter or per square foot is over 700% higher because of this cluster effect and because they are vertical instead of horizontal. So that's very important where you want to save space, and space is valuable. Now, we have aluminum blades as a version. They're a little bit cheaper, especially as you make them higher, and therefore the cost effectiveness is a little bit better. They're not as beautiful, but for some customers, it's a preference, particularly industrial customers. So these have the same aerodynamic advantages, and they're flipped back and forth so that they cover each direction very well. This just summarizes some of their advantages. They have all the same advantages, except the beauty. And this is just to show you that there's a huge target project market in the United States alone. And what's the deal that we're offering the project location? They pay us 2 cents per kilowatt hour less than what they pay their utility, so they can't lose. If we have around 10 turbines in their facility, they'll save $5,000 to $10,000 per year, and yet it's also enough to make nice dividends for the investors. They have the option to purchase after 7 years at their cost, plus the inflation rate. So if there's an inflation rate, the investors will get a capital gain from this. So the investor gets income, an asset-based investment, because you actually own part of several small wind turbines. The income is to some extent inflation protected, because also what they pay us each year is that if their bill goes up, then the amount that they pay us also goes up. And that's very important because there are a lot of predictions that the growth of data centers is taking away electricity. And when there's a shortage, prices go up. So that the data center may be able to get a special deal, but that means that prices are going up for everybody else. And if you haven't noticed and looked around, I suggest you check articles about what's happening with electricity prices. In general, they're going up throughout the country. So this gives you a diversified portfolio in different areas. And the key is that electricity prices not only will pay you decently now, if not well, but they will also rise due to AI and the data centers. So to an extent, you're protecting your income. It's like an inflation resistant bond, hopefully. So if you look here at the cost of electricity, the cost of electricity is going up higher than the consumer price index for these reasons. And Deloitte did a study of trends in utility costs, and they show that they're projected to increase by 19% in the next several years. And the reasons are data centers, extreme weather events, possibly from climate change, supply chain disruptions, and natural gas, which powers a lot of electricity in the United States. Its price is rising for all these reasons. Now, our current challenge is I'm sure you've seen that we've raised nearly $600,000 for projects, is to put the money to use as quickly as possible, because then everybody gets the highest return possible. Now, we've published the information that we have 7 signed PPAs, but they're not ready to start because we need them to provide information on their roofs and their electric bills. So it's kind of amazing how many companies don't have easy access to information on their roofs. So it sometimes takes a little bit of time to push them to find that out. So what we're trying to do is trying to get to market faster. So I'd like to tell you, and this is new material, it's not on the website, about how we're prioritizing other choices. So one is we're trying to prioritize Hawaii. Hawaii is an area where the cost of electricity is the highest in the United States, and they have consistently good wind. So I'm in active contact with some of the higher level people at University of Hawaii to find ground locations. And their top suggestion is Gilligan's Island. Now, I don't know if any of you saw Gilligan's Island, the TV show. But anyway, it was really filmed at a place called Coconut Island, which is attached to the big Hawaii island in Hawaii. And it's got a high price of electricity. It's got the University of Hawaii's Research Institute, which is has expensive electricity to deal with. So they're thinking of trying to get the where we are right now is they're trying to get the head of energy on campus to approve us to do a ground installation, which will mean much faster and there won't be much bureaucracy there, and we'll really be able to get a project started. So I hope that will be good. And also, there's a U.S. Navy base right nearby, and I hope that if we get started there, they'll see it, and that might be a route into providing electricity for the U.S. Navy. So there are other places in Hawaii. There are a ton of hotels that use up a lot of electricity. And here you see Waikiki. And the rural hotels have more ground space. I On my recent trip to Hawaii, I did meet in person with one. A lot of the times we just left information. We're busy calling them. So we're trying to follow up on that. Now, another area that's unexpected that I'm working on is the UK. It has the highest cost of electricity in Europe, and it's very windy. So this shows you one of the places that I had a follow-up conversation about today, an industrial park where there's a lot of area, and they're very interested in having clean energy there. So we're going to be pursuing that. And also, we just signed up in the UK somebody to work with us in terms of managing sales and corporate sales. And there already seems like there may be one large corporate customer that could be interested in this kind of arrangement. So we'll see, but we're including the UK now in addition to the US in terms of locations that we're looking at. And a new slant is you may have seen that we've done a lot of e-bike charging in the EU. We've probably sold 50 to 100 e-bike charging stations there, mostly to cities. And we're developing a new version that we've already beta tested about using advertising and using an app to activate these charging stations. So the idea is that we might be able to put them in for free in a number of cities and use this to create income that can be used for dividends. So if we get $20 a day, 300 days a year, that's $6,000 per year. So if it takes, let's say, $10,000, I'm picking easy figures, to set up one of these, get a permit, etc., and we're getting $6,000 per year income, um, then that's a pretty good return on investment. So I can't guarantee we'll get that from every place we go to, but I'm looking at this as one of the sources for an income stream from for this round. So that might be something that we can bring into effect a little bit sooner, and because it's on the ground, we won't have the rooftop issue to deal with. Now, one of the things that is explained, but in one of the very long SEC documents is the how to understand the economics of the investment. So I thought it would be useful to go over that for you because sometimes it's a little hard to understand these things. So I assumed that somebody's investing $1,000. It just makes the numbers easier, although the investments are in increments of 500. But let's say somebody bought 2 units and it's $1,000. So we're assuming that it's approximately a 7-year cycle, and the capital is put into um, buying one of a set of turbines or part of a set of turbines. Now, if inflation is 3% per year, that capital value is going to increase to the point that if we sell it at year 7, it's going to be worth more. So from that sale of asset at the end, this is the line where we're including it in the return on investment, is that at year 7, you're going to get this amount. It'll be a profit of $194 over your $1,000 investment here. So now we're looking at the income first. So the dividends also will go up if the price of electricity goes up each year. And the profit from the sale of tax credits, we'll try to do it in year 1. We're assuming that's going to be around $400. It could be less if we need a broker. So that would give a very big dividend, or gain, I should say, in year 1. And then you have normal gains the rest of the years, and then you have a capital gain and return of capital at year 7. So let's look at costs. So we have platform fees. We have to pay Honeycomb in order to run this. We have to pay other fees, lawyers, credit card processing, etc. Now, for maintenance, these turbines are very low maintenance, and of course, it'll be zero the first year. And I'm assuming $10 out of every $1,000 will be reserved for maintenance from that point on. There's really very little to do. All what we anticipate might be some change in the oil every 1 to 2 years. Then operating costs, again, in the first year will be a little higher, legal fees, accounting fees, etc. Then there'll be regular accounting and just miscellaneous fees. And then when we wrap up, we'll have to wrap up with various real estate legal transaction fees at the end. So here we've totaled the expenses. Now, if we take this line of the total gain and subtract the total expenses, then here's the return on dollars each year after the expenses are taken into account. And then we put the total return over here. Now, if we take the ROI in percent, then we're saying for the entire project after 7 years, 257%. This is assuming Hawaii, by the way, and that would mean a 37% per year return on investment. So even if there's some unexpected expenses or something like that, you can see why I'm trying to concentrate on getting us projects in Hawaii, because the return on investment is very high. And if we can pull off some of these, it will really be a very nice investment for your portfolio. So that explains how we calculate the potential income, subtract from it the likely expenses, and we come up with a figure that will give us your return on investment. When we do the same kind of thing for a place like Island, it's around 15%. If we do West Texas, which is very windy but doesn't have as high a cost of electricity, it's more like 12%. So whichever projects come along first are the ones that we're going to be doing. But as you see, we're working on everything from maybe 60%, 50, 60% from the charging station advertisements, down to 12% from windy places like Texas, and everything in between. It just depends what comes through first, because we want to put your money to use. So I'm sure you know how to invest. The best thing is to go to our website, because then if you sign up there, we won't lose track of you. We can get you on the mailing list, and then you can go from there to Honeycomb, where you can invest here. If you're a smaller investor, the minimum is 500, 1,000, then you can do 1,000, 1,500. The minimum is 500 in crowdfunding. If you have a family office, if you're a large investor, and you want to put in a few 100,000 or $1 million, have your own separate project company, we can do that for you. But otherwise, we want you to join one of our rounds, because it'd be difficult to combine just the paperwork for distributing the funds with two different rounds, two different platforms at the same time. So there we are. We're hoping to make a major difference in the world. And I'm now going to answer some of the questions that were on the registration, and then we'll get into your live questions. Let's see. So how the tax credits work, and is it a win for the purchaser? So the way we structured it with a separate company is that the separate company, Flower Turbines Project Series 1, is the purchaser of the turbines. Therefore, the tax credits do not go to Flower Turbines and do not go to the location where we're selling the electricity, but they go to Flower Turbines Projects, which is your investment. So that's important to understand. Let's see. So somebody asking about comparing our turbines on rooftop instead of solar. So one of the differences is that Flower Turbines doesn't have to take up the whole roof. So we could do part of each. Now, the smaller models, which are easier to put on a roof, aren't as efficient, both in terms of thermodynamic efficiency, engineering efficiency, as well as money efficiency as our larger ones. So we're taking a little bit of a hit on the roof, but if there's good wind and there are enough turbines to make a cluster, it makes up for it. So the return on investment should be within less than 10 years for turbines on a roof. And I'd say the difference between solar and wind is that solar panels would have a lower cost but a lower efficiency, whereas putting our wind turbines would have a higher cost but a higher efficiency, so that it would balance out. If it's a windy area, you'll get more from wind. If it's not a windy area, you might get more from solar. I'd like to point out that the combination of them is good for many reasons. Number one, it covers you at different times of day. Obviously, there's no such thing as lunar panels. Uh, but one of the things about that is that if you were doing a direct offset to your electricity, and there is a at 12 o'clock, there's already maximum being used for the grid. Some electric companies may not accept the excess electricity you're producing that might go to the grid. Whereas at night, they will be accepting all of it because you don't have the competition from the solar. Um, and also then you don't need as much batteries in order to run your turbines. So there's some pros and cons of both. And I would say the basic thing, it depends on your resource. If you have a good wind resource, do wind. A good solar resource, but not a good wind, do solar. And if you have both resources, do both. Um, and can I put them in my house in Connecticut? So it depends the shape of your house. We're already selling our Eco Roof system, which is made to put on flat roofs, and it uses weight and friction to hold it on, so you don't have to drill into your roof and face the risks that that has. We also have a patent on doing this for slanted roofs, but we haven't built it yet. If you're interested in being one of the first, let us know. But in general, most people have slanted roofs. A lot of multifamily dwellings, brownstone houses, things like that, tend to have flat roofs. Let's see. Give a rough time for getting these turbines up and running from PPA signing to being operational. So again, it depends on the customer. It could be 6 months. That's why we're trying to get some of these other sources of PPA and projects that could take more like 2 to 3 months to get it completely installed. Let's see. We're getting very specific now. My condo is located at 8183 Carnegie Hall, Connecticut. No, I'm sorry, Court in Vienna, Virginia. So, what I would suggest is that in general, Virginia is a lower wind area. However, there are some areas near Washington, D.C., which I think Vienna is, and near the Potomac especially, where the wind on high buildings is pretty good. So if you do that, and if you don't just get one that goes directly to your condo, but if they're a whole bunch for the condo group, for example, or even if you have many individuals, but we make a cluster for many individuals, that's really where you're going to get a decent return on it. I think just doing one at a time in that location is not going to be so cost productive. Let's see, land restrictions. Again, it's mostly rooftop problems, land restriction, no. So somebody's asking about the ROI. Again, it depends on winds and the local cost of electricity from the utility. How are you educating politicians who are paid by all lobbies to oppose any green energy? So if this is obviously something we're concerned about right now, I'm not sure if the current politicians in the government are paid off, but I think they just don't understand the benefits and the long-term benefits of renewable energy because it's really an investment in the future. I believe that oil should be put to better uses than just burning it. Oil has tremendous uses. A lot of our pharmaceuticals, clothes, medical equipment. There's so many things that are uh, made from as derivatives of oil that we really shouldn't be wasting it uh, and burning it. So we actually made a very funny bird video. Maybe some of you saw it on our website, an interview with a bird about how wonderful flower turbines are for birds. And we'd like to show that around Washington, uh, but I don't think it's caught on yet. Um, but we're trying to get there. Um, let's see. Um, is there a plan to incorporate flower turbines with horizontal axis wind turbines and that are currently in place? So they can integrate, but we could use them on the ground or a spare space, let's say around the periphery of a wind farm. And it's probably a good location because they probably picked it because it's windy in the first place. So I would think that would be useful there. And also the infrastructure would be set up for it. So I actually like that. And one of the ways I've been pursuing exactly that idea is that I've been trying to approach Hawaii Electric. And I even got one of them to connect to me on LinkedIn, and I sent him at the email that he gives on LinkedIn a proposal for Hawaii Electric. I haven't heard back from him. We're trying to get through to people at Hawaii Electric in order to pitch this to them because I think they would like this. And they have some spaces in Hawaii where they could do this. So, yes, hopefully we will do it, but it's not necessarily so easy to do. Um, yeah, so somebody is asking about the current hostility to wind in Washington. So that's more from the large wind turbines, but it affects all wind turbines really as a result of that. So I would say that I think if we point out that ours are different, obviously we're not offshore, so we don't kill whales and we don't kill birds. Um, so there are a lot of features to ours, except a lot of people don't even know that this type of turbine exists and what its benefits are. So uh, we we have to um, get the word out. Um, oh, let's see. Um, let's see. Okay, so somebody asked specific locations, so I covered that. Um, let's see. When will the first meeting have data to share? Um, so we'll let you know as soon as we do, when we have data from our current project. Um, so let's see. So some people are wondering about things like there are more questions for um, the company Flower Turbines and for this, but I'll just briefly mention them that there are certain products that we have that have been taking a long time because of supplier difficulties. And I would say write support.us at flowerturbines.com if you want a update on that. Um, but for what we're doing here, which hopefully will be mostly the power towers, aluminum, those are fairly easy to make, so we can make them pretty quickly. Maybe 1 month turnaround for that. Uh, we would love for you to bring your presentation to Evansville, Indiana. Um, oh, well, thank you. If you can get us some business there, maybe I'll have a reason to go. Um, let's see. Some people want to understand how it's going so far, so that's what we covered. Um, okay, there's some people interested in their own properties. We're glad to talk to you about it. I would say contact support.us at flowerturbines.com, and then we can uh, um, deal with your questions that way. Now, I'm going to stop sharing my screen, and if any of you want to ask questions right now, um, please go ahead. You can, if you want to, you can put on your video and ask away. So I would say uh, jump in, but just if two people are talking, uh, one of you gives way to the other.
Daniel, you might look at the chat window. There's a bunch of questions that have been asked in that live
Okay,
chat.
so let me address these. Um, would these units qualify as depreciable equipment for the project? Yes, they would. Um, what we're thinking, because depreciation kind of complicates the accounting, and I want to show people how the real project is doing because it's kind of an accounting, uh, say, accounting trick, sort of. Um, but yes, there is depreciation, and we pretty much decided that we're going to apply depreciation to the capital gains of the turbine at the end, so that hopefully there'd be no capital gains tax uh, from it. But we might be able to distribute. We'll see. Uh, it'll depend on our accounting, but we might distribute some of the depreciation, which you can pass on to your tax return each year. So it'll really depend on what is going to do best for the project. We're going to be following that. So yes, that would reduce upfront expenses, but of course you have to pay it back in the end. Um, let's see. Was lifespan of the turbines? We built them so they last 40 years. Um, the bearings might have to be replaced after 20 years, um, but they're built for 20 to 40. Okay, what happens after year 7? So we're going to try to sell it to year 7 and year 7 to the location. If they don't buy, um, we're going to look at other things like either selling it to the other projects that we may be making in the future, or packaging them and selling them to an insurance company so that they have a portfolio of income producing projects. That's something a lot of insurance companies do. Or else we won't be able to close the fund at 7 years and you'll just keep getting dividends um, for a long period afterwards. But we're going to try to sell them off within 7 years. The reason is we did a survey uh, this spring, and most people seem to want to be able to finish the uh, the fund within 5 to 7 years and get their capital back. So that's why we pick 7. We may get a good deal at 6, we may get a good deal at 8, but we're aiming for 7. How many flower turbines are operating today? 50 to 100. So we don't have a turnkey price for the EPC because each location is different, but we figured that the turbine cost plus approximately 25% for the EPC, that's for the engineering and so forth and installation, is what we've been doing to figure out the general return on investment. The insurance is that we're going to try to get the location to put us on their insurance. Either they do something like this as a courtesy for free, or if they charge extra, it's going to be much less than our buying our own insurance for the project. Let's see. What is the nameplate capacity of one turbine and installed cost? So again, it depends on which size. We would like to ideally put in the 8-meter high blades for the power tower because that's the most cost effective. So I forget the exact price. It's probably something like $30,000 to $35,000, and then the installation figure that would be another add 25%. It'll be in a group, so it won't be the only one done at that time. So yeah, I'm aware of wind harvest. It's a different type of turbine, and they want to put it on current wind farms. That's great. It's a good idea. I guess that's why somebody asked me about it. How are they installed on what foundation? So in general, it's best on concrete on the ground, but also some roofs have concrete or steel beams. And if not, we can use the eco roof concept for some of the smaller turbines, 1 and 2 meters high, and put those on top of a roof. So yes, we're planning to record this, put it up on the internet, and then send out links to on Honeycomb so that everybody, or on our excuse me, well, hard to talk so much, or we'll send it out in our regular updates, so you'll have a link to it. Okay, so I've covered the chat. Are there any questions anybody else would like to ask? Just go ahead and speak up. If not, I think we can stop the recording. And so I'm going to stop